We are going to see the binary search tree iterator question 173. Implement the binary search iterator class that represent an iterator over in-order traversal of a BST, and the BST iterator tree node root initializes the object of BST iterator class. The root of the BST is given as the part of the constructor. The pointer should be initialized to a non-existence number smaller than any element in the BST. So BST iterator is just a constructor in which the root is passed as the parameter, and the pointer is should be initialized to a non-existence number smaller than any element in the BST. That element, it would start with the element which should not be present in the BST, and it should be the smallest, less than the smallest element. And boolean has next is a function of boolean type which return true if there exists a number in the traversal to the right of the pointer, otherwise we have to return false, as it is given in the question to find the in-order iterator over the in-order traversal. So any of the node which would lie at the left of the root node, then it leftmost part will be taken first, because the least element present in the left, or the leftmost element present in the left subtree of the root will be the least element, and the right subtree of the root, if we take a look at the right subtree of the root, then just next right to its leftmost node. That means if we take a root, then it for the right subtree part we have to take the just next right and the leftmost element, that is the leftmost element in the right subtree, we have to make it as the next element, and we have to return that in the next function. So let us see the code of the question. Here is the code of the question. So in the BST iterator iterator part, the root is passed as the parameter. So first we have taken a tree node type of current variable, and we have initialized that current with the root. Until the current is present, we have to look the left part of the current. That is the Morris traversal technique we have used, in which the big of 1 space complexity is used. And we can solve this problem in big of 1 space complexity rather than using a vector to store the in-order traversal. So if current is present, till the current is present, if current left is not present, then we have to move towards the current right, and else we have to use a current pre which should be initialized with just the current left. For example, if I would take this as the root node, just left part, and suppose there is tree like this and this part. So if its left is present, then we have to make the pre as the left, and then we have to move the rightmost node of the pre, that is if pre right, then and not equal to null, and there is not a thread that is used in Morris traversal. Till the thread is not present, pre right not equal to cur. In thread, the nodes are connected with the root node using a thread, or the null pointers are connected to save the null pointers. Threads are used to connect them with the root. So till the pre write not equal to current, we have to move pre equal to pre write, and then else if pre write equal to null, if pre write is null, then we have to connect the pre write equal to cur, and then we have to move cur to cur left if further node is present. And finally we have to make the cur as the root, and we have to move till current left is present, and this is the Morris traversal technique. And in the next part, in temp is used as a current value, and tree node pre is used as current initially used to store the temporary vector is used to, and the temporary tree node type is used to store the current till current right is present. If current right is not present, then we have to make current null, and we have to return the temp value, that is the current value. And if current right is present, then we have to move current right until current that is this is, if this is the root node and it is having the right, just immediate right node as this node, then we have to move the leftmost part of this right node present just next to the right of the root node. So then then we have to move the current to the last, and we have to compare the value. If current value is less than the temp, we have to make that current as the pre write. that is pre was present initially as the root node, and we have to make its right as the current, and finally we have to return the temp value, otherwise we have to return -1. And the bool next function is used if there is current, then we have to return true, if not then we have to return false. So this is the code. Thank you.